We have a MacBook Air, and it's a no power. The description says it's a no power, and it's A1466. So, as you guys know, the first thing we do regarding no powers is we first define the state of the machine before we plug power to it. See, most of the screws on this ones are missing. Okay. Okay, with the JTAG, we can confirm that this is a 2013-2014 MacBook Air. And yeah, it looks pretty beaten up. Okay. So first and first, we are going to disconnect the battery. We have a missing screw here. It looks like it's been attempted, but I guess there was no board attempt. It looks clean from this angle. Um, let's test it out a bit. Let's see if we have any short on our PP3V42 and PP1. So, so this is going to be an 80-3437. But then you still can use 00165 board view for it. This is 00165. You can use the same board view. You see the difference. The difference that you can easily spot would be the JTAG. Say with the 165 00165, you have a small JTAG, which is a 2015 2017, and with the 3437, you have a bigger. It's almost like the double the size of the 2015 2017. So let's see if we have, let's quickly check to see if we have any short PP bus. We can use this fuse to confirm that, and that will be F7140 here. Let's see if we have any short on our PP bus. We don't have a short on our PP bus. And then let's see PP3V42. We don't have a short on our PP3V42. Okay, so at this moment I think it's okay, especially because we don't see any sign of liquid. So it seems safe to connect power to the device. This is going to be using a MagSafe 2. Charger is connected. LED? No, we don't have LED on our charger. Let's see, do we have voltage on the board itself? So for voltage, we will be using our PPDCA line, which is going to be our J7000. So we can check any of these two pins here, which is this here. 2.6, okay. I guess our DC jack needs to be cleaned out. 2.6 will, let's see. Okay, let's try again. Okay. Uh, And tell me the only issue was just a DC jack. By the way, the on and off is expected on the 2013 2014. Uh, let's see. Okay, we have Apple logo, but it's we seem to. Okay, that doesn't really look like an issue with backlight. It looks like if we do a PRM reset, that should resolve it. So let's shut it down and do a PRM reset. Okay, we still don't have backlight. So I guess the description was um, I don't know. So is it like a no power and a backlight issue, or maybe it was a backlight issue all along and the description was wrong maybe? Okay, let's see what we have on our backlight output. And so for the backlight output, we are going to be utilizing the caps and the backlight output line. So here we are going to, let's see what we have on our backlight output. Okay, we're getting zero on our backlight output. So let's see, what do we have voltage on our fuse in and out? F7700 is going to be our voltage into our our backlight circuitry. So if we have a blown fuse, that may explain why we will have 0 volt on our backlight output. And also, if we have a short on our backlight output, that will also explain why we'll have a 0 volt on our backlight output. And also, if we sometimes it will be the case of the spin not being detected. Obviously, that which means backlight will not be active. But in this case, we have image on our screen. We just don't have backlight. So let's see what we have in our fuse. So we're expecting to have 8.6 volt here, 8.6 volt on PB bus, as well as 8.6 volt on the input of our backlight. So let's see what we have. On no, 8.5. Okay, and then the other side, what do we have? 8.5. Okay, so we do not have a blown fuse. Okay, that's fine. Let's just check that again. And let's see, do we have image still on our screen? Okay, we still have image on our screen, and for some reason, it's still booting because we just have an Apple logo. Okay, let us let's take our board out and then get to understand what's happening. This is actually wrong. This is a wrong screw. That's not supposed to be there. It's actually so they swapped it. Yeah. So this is supposed to be here. Okay. Hmm. Okay. What is that? Interesting. Okay, we are going to check that out. Sorry, this one. So, let's see what this is. Let's get a donor board. Sorry. Let's see what was here. Yeah. Okay. See what that. See what that is. That seems to be U8030, which is the SO regulator, BP3B3 SO regulator. Is that what it is? Here. It's um, here we are 34, 37. Oh, okay, this is our guy here. It's a U3550, and that is for Wi-Fi. Hmm. Okay, that's for Wi-Fi. That is a 3.3 volt for Wi-Fi. Hmm. So okay. That's really bad. It's so let's see. Now, let's see. Do we now have a short because of that? Let's see. Do we have a short? Yeah. And hmm. Okay. Let's try to dig out. Let's try to dig out that short. See, we're making any progress. Still have a short. check that again. Hmm. Let's see. So we expect the shorts to be on this side only. We expect that this side should be free of the short. So this is R5470. So we expect to have a short on this side of the board, but this side it shouldn't have a short. And then let's see what else is on. Okay. Um, let's see if we have a short on our 3.3 underscore S5. Can we measure that from? Okay, yeah. We don't have a short on S5. Let's say we definitely don't have a short on pin 6. So our short would only be on. So what we can do is we can get this like this voltage, this 3.3 volts from a different source, and then attach it to R5470. Yeah, we can do that, and then let's see. And then in terms of okay, let's see now. It's we expect to have a short on this side still. No, we don't have a short here on the other side. Ah, okay. So here, ah, okay. So let's remove this. Hmm. I guess that was our problem. Okay, let's see. Hmm. So that was the problem. So the problem was the Wi-Fi card, specifically a damaged capacitor on the Wi-Fi card, and then it created so much damage on the board. Hmm. Okay, so what we're going to do is we will be attaching a different power line to this as a source for R5470 because this is completely unusable right now. So we are not going to see this. So, okay. Let's put this back. Okay, now we are going to look for a source to replace our PP3V3 to replace our E3550 for the 3.3 volt. Let's see. Let's see, what is this? SO. Hmm. Um, so, provided we have SMC Wi-Fi power enabled, if we get a 3.3 volt line from a different source, that should be okay. Do you understand? So, in order for this section, in order for this circuitator to function, two things are required. In order for you to have output on U3550, two things are required. Number one is you need power to the chip itself, which is going to be on pin 2 and pin 4. Number two is you need an enabler, which is to basically, it's more like a switch to turn it on. So that is going to come from SMC underscore Wi-Fi underscore PW underscore EN. So that's power. So now, if we have this, then it means then if we have that and then this, then definitely we will get output, which is on pin 1 and 2, and then this is ground. So what we want to do now is we want to get a different output to power R5470. Do you understand? But that should work okay if SMC power, if the SMC enabler is present. Even though we don't want to use this section, yeah. But then that signal has to be present on the board. I don't know if you understand. So let's see if that's present. Let's get it. Also, we may as well check if we now have backlight because this might just be related somehow. Screen is broken, but it's enough to give us what we need in terms of backlight. So this is standard for 20. This is only for 2013, 2014. 2015, if 2015 does this, then that's quarterfinal screen. That's a different issue on its own. 2012 is also not going to do this, and then 2011 is not going to do it. So okay, yeah, we definitely do have issues with backlight still. So it's very funny. It's almost like there are multiple issues with this machine. Okay, so yeah, so let's see. Okay, we can disconnect the screen. That will give us a better room for. We want to confirm that the SMC enabled signal for Wi-Fi is present, and then we can get a different source for the 3.3 volt line. So we're just gonna do that the second time, and then the third it should pick up. Okay, let's go to the other side of the board. Uh, we can get that signal here, which is this point here. We can get the signal there. Let's see if that signal is present. Okay, 3.4, yeah, that's great. So the signal is present. So we can get a 3.3 volt from a different source. So we can, let's see, can we get that from here? U8030, although, yeah, if we get it from here, it means, yeah, we can get it from here. Yeah, let's do that. Uh, yeah, let's get it from here. So we can attach a wire at R5440 to go to R54. Yeah. So we just need a wire here to here. Okay, let's do that. Mm, so actually, that's not present on the board. R5440 is not present on the board. This is the space here. So we will attach a wire from this point to this point. Let's do that. Uh, uh, so, so, Okay, that's done. Let's just save this. Okay, so we have power to the screen. I'm not sure if you guys can see that we have power to the screen. Let's just confirm that we have PP3v3 on. Okay, so we have okay, yeah, no, that's fine. So now let's now work on our backlight. Let's see why we do not have a backlight. So let's start from the other side, which is let's work our way up. F7700. So let us open the schematic. It is 0-3437. Open. It is 0-3437. So let's go to F7700. F7700. So this is the backlight. This is the backlight region, and then here we see that it comprises of actually two backlights, which is the LCD and the keyboard backlight. So we have the LCD backlight as well as the keyboard backlight. So this is this section here. It's for the keyboard as well as the LCD. So right now we actually very much concerned about the keyboard, the LCD backlight. So we are going to start our troubleshooting from here. Now, this is the beginning of our backlight circuitry, where we have a PP bus coming into a fuse. Now, this fuse is then going to pass through Q7706. Now, Q7706, it's a P-type channel MOSFET. So what that will mean is we will have voltage on pin 4, and then in order for this MOSFET to open, the voltage on pin 3, the voltage on the gate has to be lower than the voltage on the source. That is what is a P. So that's going to be like so that's a P channel. But if it's an N channel, the voltage on the source will be greater or equal to the voltage on the gate. But because this is a P-channel MOSFET, so the voltage on the source has to be lower than the voltage on the voltage on the gate has to be lower than the voltage on the source. Only then will this will this open. When it then opens, and then you now have voltage, which is that will now be utilized to basically get our backlight to be active. Now, in order for that to happen, you have two series resistors here that will serve as a voltage divider in order to lower the voltage that we get, because the same source, so these two resistors here will take the same voltage source here and then lower it in order to have a lower voltage at the gate here. Now that is going to be made possible through through this diode here. Now, in order for it to work, you need this signal, and this signal. So if these signals are not present, this is, you'll find if these signals are not present, what will happen is you have the same voltage here on your gate, and if the same voltage you have on the source is the same you have on your gate, this is not going to open. So let's check out what is happening on our Q7706. So that's Q7706, and then this is Q7706. So the source is going to be pin 4, and then the gate is going to be pin 3. So let's see, pin 4 is going to be our source. Now let's flip the board over. We're going to come back to that. Let's flip the board over. So what we're going to do is we can just flip this. like this, or we can actually just do this. So let's see what we have. We have confirmed that we have voltage on our fuse. So this is the fuse here. We have voltage in, that's the PP bus voltage, and then you have your voltage out. Now let's see what we have on Q7706. Okay, you see, which is the pin 4 of it. Now let's see what we have on the pin 3 of it. So the pin 3 should be lower, which is on the other side, and we're having 8.3 something, so that is too high. It's not going to open. So see here we have 8.6, yeah, yeah, 8.6, and then the other one we have what? Nah. So the difference is too close, so that needs to be. So then what we now want to do is we want to see if we have a problem with the voltage division. So we cannot disconnect power from the board, and I did see there's a bit of it looks like corrosion in that side. Is it corrosion or something like that? Yeah, so C7782 and R7788 are not looking okay. I'm not sure if you guys can see that. Let me just do this. Hmm. Okay, so that doesn't really look, looks like that, yeah. So what we want to do is we're going to replace these two here, and then also ensure that we have continuity between pin 4 and the pin 1 of our 77888, and then as well as a pin 1 of because if we have a break in the line, it means that the voltage division will not be able to do their work. So remember, so here you have PP bus going in and you have PP bus going out. PP bus going out to the source of Q7706. Now the same PP bus is to be taken by our, which is this two resistors here, two series resistors here, which would then act as a voltage divider. Obviously, this signal and that has to be present. But if you have a breaking line, which means if you have a breaking line, it means that these voltage dividers will not be able to carry that power to this section here. You understand? So if, for example, this voltage is supposed to have the same voltage here, the same voltage you will get here at the beginning of the resistor. But here, from here, this is where you will get the voltage drop from the side. Is where you get, yeah, is where you get the division. Now, if you don't have anything here, if you have a breaking line here, there will be nothing for this to divide. So that's what we're trying to. So let's first try to make sure. Let's replace that and make sure that that is present. Okay, so let's remove this and then we can do the measurement as well. We're still gonna come back to checking to see that the signals are present, but you see that it's something that's what. Yes. Okay, so what we want to do is that we want to ensure that we have continuity between this and this. So you see that test pad here, let's just make sure that that test pad is not broken. Uh, let's see, do we have continuity between pin 4 and our capacitor? So it's going to be from here to here. Okay, that's fine. Okay, yes, we do have continuity. So let's put that back. And then here also, okay, this are tied together. Okay, that's fine. Where's our now what time is it? Okay. So right now we are not replacing Q7700. It's Q7706 because we don't have a reason to blame it that it's faulty. So the only components to replace it's R7788 and C7782 because because of the way both components are looking. So we are now going to test it, and then we are now going to see if we have any difference. And then afterwards, what we are then going to do is we are then going to see if we have these two signals present. That is, if we don't have any changes, then we will now work our way to see if both signals are present. So let's just put this same to misbehaving. Okay, good. Ram, how are you? Okay, thank you. He's going to be here, I think, afternoon. Yeah, you can just place it anywhere. Okay. Oh, okay. So what did you say? Let him come. Yeah, just yeah. Okay, let's see if we have. Are you still working on your camera? Let's see. Okay, so we still don't have backlight. Let's now see. So we know we have 8.5 here, and then the other side we have, okay, that's fine. We have 8.5, that's okay. And then this resistor here, 8.5, 8.3, okay, 8.3. Okay, now let's see, let's check for our backlight, let's check for the enable signals, which we enable signal, LCD backlight enable on pin 3. Let's see on pin 3, see if that is present. And that is 0, so that explains why it's not opening. So this signal here, it's 0. LCD backlight enable, wait, LCD backlight enable is 0. Interesting. Wait, no. Is that enable L? LCD backlight enable L. Okay, yeah, so that's fine. So LCD backlight enable L. So what that signal means is LCD backlight enable. So this LCD backlight enable will be present if it is low.
Oh, we are getting the same.
So that is exactly what it should do. LCD backlight enable E. So if it was high, then it's a problem. Because what it says is LCD backlight underscore EN underscore L. So LCD backlight underscore EN will be active if it's low. So what we're getting is fine. So do you understand? So here it says, yeah, LCD backlight underscore EN underscore underscore. So will be present if this is low. So what we want to check to see if this is present. Do you understand?
Yeah.
EDP, let's just copy that. So that means that the fact that it is low, it's supposed to be low. Do you understand? That's what that's what it actually meant. So Q, so let's see what we have on Q. So this is what should be high. EDP underscore backlight underscore. So this definitely needs to be high. Let's see what we have there.
So we're expecting a voltage.
Yes, that's what it's meant by high. So we can use this this TP here. This one. Yeah, so that is high. That should be high. And then let's then walk our way again. And then this also, let us see if that is high. And then also that should, no, wait. So this is, yeah, so this is backlight underscore platform reset L. So this is different. So platform reset L, this needs to be high, not low. This is a platform signal. So this needs to be high and not low. No, it's fine. Don't worry. No, it's fine. Don't worry. You will you just don't worry. When we do schematic understand, and when you do schematic deep dive, then you get to understand. Because otherwise, but this now. So let's go to Q77. So it's pin 2 of Q7707. So that is going to be the pin 2. Let's use the TP on the front of it. So this one. So that is a platform reset signal. So that definitely needs to be high. Anyway, so we can confirm that this is present. So we can confirm that this signal is present. We can confirm that this signal is present, and we can confirm that this signal here, there is voltage to R7788, as well as making its way to. Now let us see. We did see 7788, but we didn't see 7789. So let's see. So this is 7788. Okay, this is 7789. So let's see what we have on the top and the bottom of it. Okay, and then the bottom of it, 0. Let's see, which is fine. Yeah, which is fine. So let's, I mean, given what we have now, so we want to now go ahead and replace Q7706. So let's replace Q7706.
Or means all the values they are bringing the right
Yeah, but
voltages.
yeah. So we have all that we need, which is Q7706 should be opening, but it's
Yeah.
still not opening. So now we want to replace Q7706 and see if we have a different result. And then also something that we did not confirm is if we have a short on our backlight output that we didn't confirm. Okay, so we will confirm that as soon as we do the replacement. Okay. And let's confirm that we don't have a short on our backlight output. Diode mode. The diode mode, we will have a red probe on ground, and then a black probe will be our guide. So here, let's see, that should be ground, 0 point, yeah, that's fine. And then on the other side, 0, 4, okay, isn't that low? Okay, it's still reading. But let's get another board. Uh, can you have those ones? No, 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 down. Yeah. Let's see what we should be having on. Okay, so 06. Okay. Um, that should be enough. That should be, yeah, that's fine. And yeah, so usually another thing also, when you work in a particular region, and then that region it's say when it's hot, and then you make diode board measurements there, there's a tendency of getting accurate result until the board cools down. So let's just see. Uh, so yeah, it keeps increasing. Okay, that's fine. So now let us see if we have anything different. See, up until now, we are still not worried about the backlight driver itself. So because we're not there yet. Okay, so now we have backlight. So now let us see what we have on. Um, let's see what we have on. Let's see what we have on the pin 3. Initially, we are getting 8.3, correct? Which was high. So now let's see. So here at the beginning, we have 8.5, 8.5, and then the other side, what do we have? Let's check that again. You see that? So,
Mhm.
you see the huge difference between what is it called, what it was and what it is now. So now that the next thing we can now check for now is now to, so remember this machine. I'm going to say just it has multiple issues. First was the charging port, and then the second was the Wi-Fi, and then backlight. So we charging port, we just needed to scratch that out. The Wi-Fi we had to do like a jumper. So which we're now going to go back to the Wi-Fi now to see if that works the way we want it to work. So and then something else. So this is where I always want to say that let your multimeter guide you. Let your schematic um, help you navigate through your troubleshooting. So you don't just assume, okay, I have backlight issue, replace fuse. I have backlight issue, replace the backlight driver. Now this is the backlight driver, which is 7701. Up until we conclude our troubleshooting here, we are not going to move here. So you have to move in sequence, and each sequence, each stage has to be informed. I mean, you have to have a reason for being there. Do you understand? You don't say, okay, because backlight issue, replace backlight driver. Backlight issue, replace the fuse. If you're replacing the fuse, you have to have a reason why you're doing so. If you're replacing the backlight driver itself, you have to have a reason why you're doing so. So, like I was mentioning, when we do a deep dive into a schematic, you get to understand how this. But it's very easy to understand. And this is the beauty of this. If you can understand one page, you can use that to apply to every page. You just need to get the basics. Do you understand? Once you get the basics, then everything else is easy because it's written in front of you. You can see it. Do you understand? So, for example, when I talked about Q7706 being a P-type channel, MOSFET, you see it's actually written there. Yeah. So it says MOSFET. This is the ID, and then the channel is P-type, and then so you see the information is there. Do you understand? So yeah, pretty much. So the next thing we want to do is we now want to go to our Wi-Fi. So let's hope that that works. So definitely we're not going to use that card. So let's use a different card. This doesn't really look uh, too good. Yeah, it's definitely not good. Okay. This one, yeah, let's see if we can find another one. And but it should have a card. Yeah, that has a card. Okay, let's check this one. Okay, this looks good. And then you also saw how your Wi-Fi cards issue can,
Stop
yeah,
the machine to.
yeah, but I mean obviously because remember the cap, it's shorted,
Yeah.
so that will definitely affect the overall function. Okay, here. What time is it now? 9 o'clock. Okay, so 10 minutes past one. It's Friday. We need to leave as soon as possible. Okay, let's see what we have on our Wi-Fi. If we can get this to a point, then Peter can then finalize, take it from there. We don't really need the cable to do the testing, so I don't even see why I'm having the cable connected. So we don't for the purpose of the testing, the cable is not required. So hold down our Alt key.
That machine, when we disconnect to the signal, it is
Oh
going.
yeah, yeah. I completely forgot. We didn't. Yeah. So cable needs to be. That was a newer design. You remember?
Yeah, it was a new design. Yeah.
Yeah. Okay. Wait, I don't see nothing. Okay, yeah, we do have backlight. Just waiting for it to. Waiting for image to show up. Should we do a PM reset? Because we don't want this to waste our time. Uh, what if the fact that wait, we want this to it seems our key it's not. So let's try the other one. Yeah, the key the key didn't work. So let's try the other key. Let's try this one here.
I mean, that might explain the reason why it's taking very long.
So which means the pyramid that we did at the time was not successful. Uh, what? Wait, is the keyboard connected? Keyboard is connected, so why isn't it responding? Okay, let's use an listener keyboard real quick. Usman, help us with that keyboard. We're gonna get back to we will go to that. So I hope the keyboard is also not faulty. It's yeah, it's just gonna have like too many. Let's say caps lock. So yeah, we can use the USB here. It's on board, but that needs a cable, iBoard cable. Uh, okay. Caps lock doesn't seem to be responding. What time is it? 14. And this is annoyingly slow. Okay, caps lock is responding now, so it's shut it down. So you don't have time to wait for this to go up. And then try again. Hold the Alt key. If it doesn't work, we may have to disconnect the internal keyboard. The internal keyboard might be, yeah. Uh, this is so annoying. Okay, internal keyboard will have to be disconnected. But if we then disconnect the internal keyboard, it means you have to.
Mouse also, yes, we did it.
No, it means you have to disconnect the charger, and then if you disconnect the charger, in order to power it on. Uh, okay. Yeah, because remember the power button is no longer because of this one. So now you have to, and then to use a charger, you have uh, to do it on and off, on and off, on and off. So you see the on and off, that is only on cold boot, not on warm boot. So if you shut the machine down, for example, the machine is still you still have power on the machine and then you restart it, it's not gonna go on and off. No, it's just
Just
gonna,
like
yeah,
switching.
yeah. So it's only on cold boot. That's when so let's see. Wi-Fi is working. So, so yeah. So we have Wi-Fi, we have power, we have backlight. So yeah, it's sorted. But just that this machine is old and it has too many issues that I'm not sure how this client is going to deal with all of it. I mean, I don't know. Yeah. So Peter, I leave this to you to finalize. So yeah, this machine has three issues: DC jack, Wi-Fi, and backlight. So DC jack just needed to be scratched out. Wi-Fi, you guys see we have Wi-Fi, backlight, and you guys can see that we have backlight. So the other thing that we now need to deal with is now the keyboard. So definitely, yeah, I'm not sure how this guy is gonna deal with that, but yeah, they may have to also replace the keyboard. Okay, thank you guys. I will see you guys in the next one.